We're going to take a look at Chapter 6, Lesson 4 on dilations. It is the last of our 4 transformations. A dilation is a transformation that produces an image that is the same shape as the original, but is a different size. A dilation enlarges or shrinks the original picture, the original figure. Scale factor of a dilation is what you're multiplying by, and we are going to call that scale factor K. Remember, dilations are bigger or smaller. A figure and its dilations are the same shape. If you look off to the right, we have right triangles, 2 of them, and let's point out that we have, of these 2 shapes, that since this A does not have the tick mark on it, it means that the original triangle is this large one, while since this is A prime, the smaller triangle is our dilated picture, meaning this one shrunk what we had. Now let's explore what makes a dilation versus it being a totally different picture. It says find the scale factor for the dilation that maps the solid line figure onto the dashed figure. This means we are solving for K. I'll warn you that K is either going to be a whole number or a fraction. Whole number or a fraction for our purposes. Let's go ahead and look at number 1. The solid line figure is this larger rectangle, and we see at the bottom it has 2 measurements, 4 and 4. What that means is the total length there is 8. And what we want to decide is from the large triangle to the bottom one, what is the scale factor? In order to find the scale factor, we're going to take the new measurement and divide it by the old measurement. So in this example, the new one is 4, the old one is 8, and we know to always reduce our fractions. I almost went and did the wrong division. I know it can be bigger than 2. We're going to use 4 to give us a fraction of 1/2. So K is 1/2. That is my scale factor. Now let's look at the second one. We have to figure out how to take that small parallelogram and stretch it out into the larger parallelogram. Now, let's use some critical thinking. When I took a big shape to a smaller shape, notice that the scale factor was a fraction. Well, if I go from a small shape to a larger shape, am I going to multiply by a whole number or a fraction? In this case, as in every case, when I go and enlarge or stretch out my picture, my scale factor is going to be a whole number. Let's see what we can come up with. Now we need to figure out a measurement for this parallelogram. And what I see is this first one has a height from 0 to -2 of 2. Well, what is the height of the bigger parallelogram? From 2 all the way down to -4, that is a distance of, let's see, 1, 2, 3, 4, 5, 6. And I have my two measurements I can use. If the scale factor is going to be found by taking the new measurement and dividing it by the old measurement, I'm going to have 6 divided by 2, which is 3 as my scale factor. And as stated before, since it was getting larger, it had to be a whole number, and that's exactly what we have. So that is how we find the scale factor. Take the new measurement, divide it by the old measurement, and that'll tell us what we multiply by to perform this dilation. Check out these next two. And in these, we want to determine if one figure is a dilation of the other. Let's look at the two shapes on the left. Those are pentagons. And we're going to look at the sides that match each other. All those corresponding parts. If we look at the 3 and the 6, I want to figure out if they are changing by the same factor as 5 and 10. Well, as we notice, to go from 3 to 6, we could just multiply by 2. From 5 to 10, we can also multiply by 2. Therefore, this is a dilation with a scale factor of 2. Now, there's another way we could have found that. To be mathematically more correct, we could look at taking the new measurement versus the old measurement. And if we say that the bigger shape is the new measurement, we would have 10 divided by 5 and 6 divided by 3. But I want to know, are these equal? We end up with 2 equals 2, so that is correct, and that is why this is a dilation. Now we have these snowman shapes over to the right. We can see the heights of each of these circles. If we start from the bottom up, I have a circle that is 2 spaces tall. And when I look at what it transforms into, it's the same. Well, we could have a scale factor of 1 in a sense. But if we look, the midsections stay the same, but look at the heads. From the left to the right, the heads actually have a scale factor of 2. Since these are not the same scale factor, this is not a dilation. They need to be the same scale factor. So we want to know if it's the same scale factor. Now, let's take a look at what this looks like on a graph. So here we go. If I have this graph, I want to see if I could figure out what is the scale factor from the pink shape to the blue shape. One approach to this would be to find the lengths of one side of the pink triangle and then the corresponding side of the blue triangle. Let's find the distance for A to B. So I'm going to look at these 2 points. Well, what I need to do is find that from -2 to 1, that is a distance of 3, and I'm going to use Pythagorean theorem. From -2 to -1, that's a distance of 1. And I'm going to figure out what that missing piece is. 9 plus 1 equals c squared. Take the square root of 10. I find that c equals and I'm going to check my calculator to make sure I get this right. 3.2, because I'm going to round it off. So this is 3.2. What I want to now find is from A prime to B prime. From -4 to 2, that is a distance of 6. From -4 to -2, that's a distance of 2. Now, we might start to see, maybe this is telling us we have a scale factor of 2. Just to be certain, let's see what we can come up with. 6 squared is 36 plus 4 equals c squared. That's 40 equals c squared. Square root will tell me that c is equal to 6 point, I'm going to round it off to 3. As we talked about before, I'm going to take the new measurement, divide it by the old. So I'm going to take 6.3 and divide it by 3.2. And it comes out to 1.96. I'm going to round that off to say 2. As I look at this, this is one way, but I want to take a different approach. So I'm going to clear this, and I want to see if we can find it another way. Now, for dilation, we have a rule that we take the xy and we multiply it by that factor k. So let's see if we can't figure out, say, how they took a, which was -2 and -2, and turned it into a prime of -4, -4. What's great about that is if we look, we could find it by dividing. If we take -4 divided by -2, we get 2. If we do -4 divided by -2, we also get 2. So what we find is that we took a, took the -2, multiplied them each by a scale factor of 2, to help me get my a prime. So we have a scale factor of 2. let's look at that for example 2. Sorry, I just want to get these moved out of the way. So for example 2, I can look at my ordered pairs. Now, in this case, for this shrink, because we see that it goes from the green to the red, their A's are the same. So I'm not going to look at their A's. Let's look at maybe the B's. How could I go from B, which is at 3, 3, 3 times K, and 3 times K became B prime, which is at 1, comma 1. I can think about this as two small equations, where I'm doing 3K equals 1, and I want to solve for K. In order to do that, I must divide by 3, and I find a scale factor of 1/3. And we could check that with any of the points. When you do each of them, you will find that K still stays 1/3. Let's take a look at number 3. Under a dilation, triangle ABC becomes triangle A prime, B prime, C prime. What is the scale factor? So here's what I'm trying to figure out, is if I have my original ordered pairs, and I multiply them by K, how do I get my new coordinates? Now, unfortunately, A doesn't help us because it's 0, 0. So let's see if we can't figure this out for B, which is at 0, 10. I want to figure out what their K is. Oh, I'm sorry, I have that backwards because in the first one, that's not 10. That is 4. What I can use is I can use this 4 times K equals 10. That'll help me. If I go and I solve this by dividing, I find that K is equal to 10/4. But as good math students, we don't leave it like that. We reduce this down to 5/2. Let's double check to make sure this works out by checking out point C. In point C, I have 15, 0, and I'm multiplying them both by K. In order to find C prime, which is at, I'm sorry, I did that again where I have this backwards. This should say 6. While in the new one, that's 15, comma 0. I can use the fact that 6 times K has to come out to 15, and then I divide by 6 to find K is equal to 15/6. I can reduce them both by 3 to get 5/2. So we're okay. 5/2 is our scale factor. Just wanted to take the chance to show you that if you check all the points, it should come out to the same scale factor. So you should only have to test this with one set of image and pre-image ordered pairs. Let's check that out in number 4. Now in example 4, we're not given any of the ordered pairs. So it might be helpful to first go to the graph and identify our ordered pairs to help us out. So let's find point A and A prime. A is at -2, -2, while A prime is at -4, -4. Now, right now, you might be able to identify what this scale factor is. Let's check it out to be 100% sure. A, which is at -2, I'm going to multiply it by K. -2, I'm going to multiply it by K to see how that becomes A prime at -4, -4. We can use the fact that -2K equals -4. And when I divide, I find that our scale factor is 2. If we multiply every ordered pair of A, B, C by 2, we will find the ordered pairs for A prime, B prime, and C prime. Let's do this the other direction, and if we're given a scale factor, let's go ahead and find what the new dilated picture would look like. So here we go. In number 5, we need to start by finding what our ordered pairs are. We have that A is at 0, 3. And actually, I'm going to leave some space because we're going to go ahead and put in there what our multiplication is as we figure it out. 0 and 3. B is at -3, -3. And then C is at 3, -1. And we're going to go back and look at our scale factor. If we go back up to the instructions, we can see that we're asked to use a scale factor of 1/4. So I'm going to go and write 1/4 for each of these, because that is what I'm going to multiply. So 1/4 is going to go in each blank. So my new sets of ordered pairs are 0 times 1/4 is 0. And then 3 times 1/4 is 3/4. So yes, we're going to have to do a fraction. For B prime, I get -3/4, comma, -3/4. And then for C prime, I get +3/4 and then -1/4. And then to finish this, you have to graph these ordered pairs on that graph. I understand, not super easy to do 3/4, but we're going to do the best we can. For A prime, 3/4 is going to be between 0 and 1. But what you have to decide is it closer to 0 or closer to 1? It's closer to 1, so we're going to go right here. It's not on 1, but it's also not right in between. So it's just going to be a little bit closer to 1. B prime being -3/4, -3/4. This is actually not going to be on any grid line. It's going to take place here, kind of in the corner of that box. And then for C prime, 3/4 and -1/4. -1/4 is closer to 1. Closer to 0. So it's going to sit right here. And then if I make my triangle, I have my dilated picture, a shrunken version of this triangle. Let's do this one more time with example 6. And for example 6, I'm going to go ahead and zoom in a little bit so that we can do it all just on that graph. So here we go. And I'm trying to avoid that thing on my screen. Okay. We want to dilate this triangle by a scale factor of 2.5. That's okay. What we're going to do is we're going to take A and multiply both numbers by 2.5. And it's going to give me a new ordered pair of A prime, which is at 2.5, 2.5. For B, it's at 2, 3, but I need to multiply by 2.5. And I should end up with a new set of ordered pairs. Let's see, 2 times 2.5 is 5. 3 times 2.5 is, let's see, 7.5. I'm going to actually move this work out of the way here in a second. Let's go ahead and find C prime. C, which is at 4, 1, I'm going to take each number and multiply it by the scale factor. To find C prime, which is at, let's see, 2.5 times 4 is 10, comma, 2.5. Now, if you haven't noticed, this chart doesn't go to some of those numbers. So we're going to graph it the best we can. For A prime, for 2.5, that's 2.5. So I would go to the 1 to the 2, halfway in between, and then up the same number, and it's going to end up right here in the middle. That's A prime. B prime is at 5 and 7.5. Now the thing is, 5 is right here. So I need to go up 5, which lands... Actually, I can go up 6. 6 is the highest number on this graph. I need to go 7. I'm actually going to go up one more, and then I'm going to use my best guess at what halfway would be. I'm going to end up with a point right about up here. And that's B prime. And then for C prime, we're going to have to get a little creative with this. Being at 10 and 2.5. I know where 5's at, and I know where 0's at. I'm going to use my best guess at how far 10 should be, right about here. And then up 2.5 puts a coordinate of C prime roughly here. You won't have any that require this much careful, this much trouble, but it should be expected that we could give you one like this and you could do your best guess at making the triangle. This is all we do for dilations. It's a lot of multiplying, a lot of dividing to either find new ordered pairs or to find what the scale factor was.